So smoke taint's currently assessed by and large by sensory analysis of juice and wine samples in combination with quantification of guaiacol and to a lesser extent 4-methyl-guaiacol by gas chromatography mass spectrometry techniques. As Kristen said earlier, in one of her earliest experiments, what we found was that a range of volatile phenols, guaiacol, 4-methyl-guaiacol, but also 4-methyl-guaiacol and 4-ethyl-phenol were identified in wines made from grapes that were exposed to smoke post-harvest, but the origin of these volatiles was attributed to smoke exposure because they were absent in the control wines. I think it's important to recognise that in the majority of commercial wines, guaiacol and 4-methyl-guaiacol are actually associated with oak maturation, and these compounds are routinely identified in oak-aged wines at concentrations for guaiacol between 10 and 100 micrograms per litre, and for 4-methyl-guaiacol between 1 and 20 micrograms per litre. And with regards to oak maturation, these compounds are derived from oak wood lignin, which is degraded during the toasting process of oak cooperage, and obviously there's some similarities to the pyrolytic processes that are taking place during the toasting of the interior of an oak barrel and the combustion of plant material, such as in a fire. In contrast, 4-ethyl-guaiacol and 4-ethyl-phenol are typically associated with Brettanomyces and Decara spoilage, and these compounds are derived from bacterial degradation of grape-derived hydroxycinnamic acids. So the origin of these compounds in wine is quite different when we talk about smoke taint to when we talk about oak maturation or Brettanomyces spoilage. So I guess what I'm trying to get at is that the volatile phenols are very useful indicator compounds for us, but we know now that they're not solely responsible for smoke taint. We've observed wines which exhibit smoke taint but have guaiacol levels far below what we can see in an oak-aged wine, which doesn't exhibit smoke taint. And we also know that we can blend smoke-tainted wines so that their guaiacol and 4-methyl-guaiacol levels are sub-threshold, but the smoke taint is still perceptible. And obviously, the identity of other volatile smoke components that contribute to taint remains unknown, and I think this is one area of research that we really need to focus on now to try and elucidate what these other compounds are. And this is actually just one of the issues regarding the assessment of smoke taint. We've also been thinking for a little while now that some volatile compounds may actually accumulate in grapes as non-volatile, sensorially inactive conjugates. And therefore, from this perspective, they can't be detected by either sensory or GCMS methods, which means when we're assessing our juice or our berries, we're not actually picking these compounds up. There was also one other issue that sort of came out of the 2007 season in Victoria, and that was that sometimes GCMS analysis can be time consuming. Now for an individual analysis, a run might only take half an hour and the processing might take an hour. But when you've got a peak high demand and you've got lots and lots of grape growers and wine makers trying to get samples analysed all at the one time, you can get a backlog of samples. And so there was an issue with results not always being available in a time frame that facilitates decision making during vintage, so whether or not to harvest grapes and winemaking decisions, how to treat grapes. So this was another issue. And I guess as a result of these particular issues, with GWRDC funding, we've established 2 new PhD projects this year at the University of Adelaide to specifically address these problems. The first project is being undertaken by a student called Anthea Fudge and is titled The Analysis of Smoke-Derived Volatile Compounds in Wine. Anthea's only started a few months ago and is in the stages of literature review, so I'll give a brief overview of what her project is about. The second project is being undertaken by Kerry Dungy and is entitled Accumulation of Smoke-Derived Volatile Compounds in Grapes. And Kerry's been on board since the beginning of January and has made some quite good progress in this area, so I'll talk predominantly on her research. I should point out that both of these projects are in collaboration with the Australian Wine Research Institute and are aligned with Kristen Kennison's work. So Anthea's project really has 2 main aims. The first one is specifically to identify other volatile components of smoke that are responsible for smoke taint. And once we know what the nature of these compounds are, we can develop analytical methods for their quantification. And we've got two real approaches to this particular project. One is a direct approach, so based on analysis of the scientific literature, because there's quite a lot of information on smoke composition and on the composition of liquid flavourings, liquid smoke. Based on that literature, we've identified a couple of classes of compounds that we think might be likely candidates. So essentially compounds that are identified in smoke and have been attributed to smoky type aromas. We've also got an indirect approach, and this will essentially comprise GC sniff or GC olfactometry analysis. We hope to identify some of the compounds in the wine that give rise to smoky character. The second part of this of Anthea's project is essentially to evaluate UV visible near-infrared and mid-infrared spectroscopy techniques as a rapid analytical technique. So these spectroscopic techniques have been quite useful in quality control and quality assurance processes for both wine and other food and beverage industries. And so there's a potential here for us to utilise this technology with regards to smoke taint. So the aim of this project will be to source a range of commercial wines that exhibit smoke taint, as well as their corresponding controls. So this might be wines from a previous vintage or a later vintage where there was no smoke exposure. We'll then analyse these wines across the spectroscopic range, as well as conduct the traditional GCMS and sensory analysis. So the GCMS analysis will include quantification of the volatile phenols, in addition to any of the other analytes that Anthea's already established methods for. The sensory analysis will include descriptive analysis, but probably predominantly smoke aroma intensity ratings. We then hope to correlate the spectral, chemical and sensory data using multivariate analysis to evaluate whether this technique can predict a smoke-tainted wine or not.